Hi, and welcome to AP Chemistry Review. It's me, Dr. V, and we're here to go through a free response question from the 2022 AP Chemistry exam. It's always a good day to study chemistry. In this webcast, we're going to talk about free response question number 6 from the 2022 exam. And it's one of the short free response questions, and that means it's scored out of 4 points. Typically what we see with the short free response questions is they may have 2, 3, or even 4 parts. If you don't already have your calculator and your periodic table and your AP Chem formula sheet handy, I would go get them right now. What I always recommend is that you listen to me introduce each part of the problem, and then I want you to pause the webcast, try to answer it on your own, and then listen to my solution. And I also want you to keep track of your score as you go. Did you earn the point? Did you not earn the point? And how do you need to enhance your own answer so that you're really getting to the heart of the question, showing off all your chemistry knowledge that you've worked so hard to learn this year? All right, let's jump right into the problem. A student wants to determine the concentration of permanganate ion, MnO4-, in a solution. The student plans to use colorimetric analysis because solutions containing permanganate ion have a purple color. And the next thing we're given is an absorbance spectrum for permanganate. Part A says, to determine the optimum wavelength for an experiment that measures the concentration of permanganate, the student takes a sample of the solution and measures the amount of light absorbed by the sample over a range of wavelengths. The data are plotted in the graph shown. Identify the optimum wavelength that the student should use for the experimental procedure. Well, what we want to do here is choose the wavelength that gives us the most absorbance. So we're looking for the highest absorbance on the graph, and that's right here. So we can call that lambda max if we want to, and if we go down the scale, we see that that's just at about 525 nanometers. In essence, that's our answer. The student should use a wavelength of 525 nanometers. Part A was worth 1 point, and you really just needed to write that down to earn the point for this part of the question. You didn't really have to explain how you arrived at it, you just needed to write that down. Okay, the question goes on. Part B. The student uses a stock solution of 2.40 times 10 to the minus third molar potassium permanganate to prepare the standard solutions of permanganate ion that are needed to construct a calibration curve. The potassium ion here is a spectator ion, so we're really not going to pay attention to it. B part 1 says, the student uses a 100.0 milliliter graduated cylinder to measure a certain volume of potassium permanganate stock solution, as shown as the diagram given. Oh, here it is. What volume should the student record? Now, AP Chemistry students should be able to read lab glassware and measure things precisely. What we see in this picture of the graduated cylinder is that it's marked to 1 mil intervals. And so that means we need to add one more digit for our estimated value. So our estimated digit would be in the tens place. I see that the bottom of the meniscus is right on that 92 line. So I'm saying that you should record this as 92.0 milliliters. And that's what you needed to write down to earn 1 point for part 1 of part B. I'm not sure if this was the question that was scored for significant figures, but my guess is this is the one. Your answer needed to be reported to the tens place, and it needed to be about 92 milliliters. Part 2 of part B says, calculate the volume in milliliters of 2.40 times 10 to the minus third molar potassium permanganate solution that is required to produce 100 mils of a standard 1.68 times 10 to the minus third molar permanganate solution. Remember, this permanganate solution is coming from the potassium permanganate, so it's all about the permanganates. The potassium ion here is a spectator. Sometimes students get confused by that. What this question really is a dilution question. M1V1 equals M2V2. I need to take a certain number of moles of permanganate and bring it up to a final volume of 100 mils so that I have the new molarity that I want. We're going to solve for a new volume, so I'm going to call that V1, and I'm going to rearrange my equation to isolate V1. And then if I go back and look at the problem, sometimes I find that labeling it or even highlighting it can be helpful, but you can't have a highlighter at the AP Chemistry exam sitting. I'm solving for a volume in milliliters. I'm calling that V1. The molarity of that original stock solution was 2.40 times 10 to the minus third molar. The final volume that I want I'm calling V2. That's 100.0 milliliters, and I want a new molarity of 1.68 times 10 to the minus third molar. Sometimes just labeling everything helps me to keep it all together. And now I can substitute into my rearranged expression to find V1. So M2 times V2 divided by M1 will give me the volume of the original stock solution that I needed, and that would be 70.0 milliliters. I do want to report my answer with 3 sig figs. I knew my molarities to 3 sig figs. I know the volume to 4 sig figs, so I'm going to report my answer with 3 sig figs. And this is the work that I needed to do to earn 1 point for part 2 of part B for this question. Make sure that you do have that complete setup for the calculation. You're not going to get full credit if all you have is an answer that comes out of nowhere. Show the math that supports your answer. The student designs the following procedure to produce a calibration curve. Step 1 is to prepare several standard solutions that have known permanganate concentrations by dilution of the stock solution. Step 2 is to rinse the cuvette with distilled water. Step 3 is to rinse the cuvette with the standard solution and fill that cuvette with the standard solution. Step 4 is to measure the absorbance of the standard solution using our colorimeter. And the last step is to repeat steps 2 through 4 for each of the standard solutions. And then what we'll do is we'll have a calibration curve. We'll be able to plot absorbance versus concentration. Assuming that all the lab equipment is functioning properly, identify which one of the procedural steps the student could have executed incorrectly that would explain why the marked data point is below the line of best fit. Justify your answer. So here's the absorbance data that we're provided with. You'll notice that most of the points are right on the line, but there's that one that's just below it. And so we really want to explain what could have happened here. What could have caused this to happen? And looking through the steps, it's pretty clear to me that it's step 3. If I had not rinsed the cuvette with the standard solution, if I went straight from step 2 to filling the cuvette with the standard solution and I didn't remember to rinse in between, that's probably going to cause that error. Step 3 is most likely where that error occurred. If the student didn't rinse the cuvette with the standard solution before filling it and doing step 4, there would have still been some residual water in the cuvette. And those tiny droplets of water in the cuvette that I didn't rinse out are going to lower the molarity of the permanganate in the solution. And if the concentration is a little bit lower, that means the absorbance is going to be a little bit lower. So that's the most likely explanation of the error. This is essentially what you needed to say to earn the 1 point. Didn't necessarily have to be quite so wordy as what I wrote here, but you have to really get to the gist of that. So how did you do? The average score on this question in 2022 was 1.97 points out of 4, so about 50%. So if you scored 2 points, you're on track. If you earned 3 or 4 points for this question, you're in really good shape. If you feel you need more review of Beer's Law, which is a really popular topic in the AP Chemistry exam, check out my YouTube video. If you found this video to be helpful, like it and leave a comment, and remember to subscribe to my channel so you get all my latest webcasts, all my review materials, and really feel ready for that AP Chemistry exam in May, which is coming up really, really soon. Remember, it's always a good day to study AP Chemistry.